All right, this video is going to go over number 21 through 30 in the quizzes review for midterm. Here we go. So find the inverse of 12x minus 3. So to get the inverse function, what you want to do is you want to switch your x and y values and then solve for y. So remember, f of x is y. So we're going to say x equals 12y minus 3. And we're going to solve for y by adding 3 to both sides. So it's going to be plus 3 plus 3, x plus 3 equals 12y. And then we're going to divide by 12 from both sides. And so y is going to be x plus 3 divided by 12. Now, we don't want to write y, we want to write the inverse notation. So f inverse x, it's just the way we write it. It means the same thing as y, but now it lets you know that you've solved for the inverse. So it's x plus, I wrote 2, should be 3 divided by 12. X plus 3 divided by 12 should be that one there. Now, if you want to check graphically, you can put the original function in, 12x minus 3, and you can put a fraction bar x plus 3 over 12, and you can see just a little bit of a comparison of points. You can see like 5, let's see, those are the same values here. Negative 3, 0 would be the same as 0, negative 3. So those y values switch, and it's the diagonal line that's intersecting it, splitting it in half, y equals x. You can see that that is the case here. All right, next question. Ooh. What is f inverse negative 3? So f inverse negative 3 means that this negative 3 is not an x value, it's a y value, because that means inverse. So when y equals negative 3, what is x? That really is what this question's saying. When y equals negative 3, what is x? And you can see that's going to be negative 6. So negative 6 will be your answer. What's the range of the function? Range is the y values. What y values can be included in this graph? So it looks like all the y values up until this one here, which is 4, including 4, and then everything below it is part of your range, because that area is going to keep going down. So everything below that is part of your range. So from negative infinity up until you hit 4, or you could say y is less than or equal to 4. Either one of those two is acceptable to describe the range. So it'll be the bracket because it includes the number. If it was an open circle at 4, it would not include it. Find the difference. Subtract the 2. So distribute that negative. So 4x squared plus x minus x squared minus 2x. Combine your like terms. 4x squared minus x squared is 3x squared. And x minus 2x is negative x. So 3x squared minus x. Number 25. Write an absolute value function given the following transformations. Reflection across the x-axis. That's a negative on the outside. Horizontal shift right 2. So that's going to be in the absolute value x minus 2. Left 2 would be x plus 2. And then vertical shift down 7 units. So outside the x absolute value is going to be minus 7. So all that together would be negative x minus 2 in the absolute values, minus 7. Feel free to graph that and check it. There's your reflection, right and down. The graph shows a function f of x equals x cubed in blue and another function g of x in red, which could be the equation for g of x. Well, in blue, the graph is x cubed. In red, it's the same graph but shifted right. And it looks like it went right 1 unit. So right 1 unit in parentheses would be x minus 1. So that's a third power, so it'll be x minus 1 to the third power. So this is the original, x to the third. This one would be parentheses x minus 1 raised to the third. And if we zoom in on that a little bit, you would see what we're talking about. '27. What are the local maxima for this graph? Maxima are points that are at the top where it starts from increasing and then goes to decreasing. So it turns around. Maximum here, maximum there. It's not the absolute because that'll go on forever, but these are local. So negative 8.5 and 2.2, 3.9. These are local minimum. These two right here. So there you go. All right, 28. When is this function increasing? Well, this function's increasing between this x value here and that x value. So it looks like it's increasing between negative 3 and positive 3. Increasing is going up as it goes to the right. So from negative 3 to positive 3. Number 29, where's the graph decreasing? Let's analyze that. The graph is decreasing here because it's going down as it goes to the right, and it's decreasing here. So it's decreasing from, since it keeps decreasing all the way from the left side forever, we start with negative infinity, and then as soon as it hits this point here, it looks like about negative 2.5, it stops decreasing. Then it starts increasing, and then right here it starts decreasing right around 0, and it stops decreasing right around positive 2.5. So those are your two intervals of decreasing. So that's going to be, well, it's not 2.5, but this is really close to 2.5, 2.55, so we'll pick that one there. 29. All right. Question number 30. Last one on here. Last one on this video. The blue dot in the graph represents that's a local minimum. All right. That would wrap up number 21 through 30.